Hello and welcome, students. Today I'm going to explain to you the air infiltration and heat conduction equations that you have under week 5 of your class. I know that some of you would like this verbal explanation because it'll help you understand those equations, even though everything you really need is written on that handout for week 5. So let's get started. The first set of equations calculates both the BTU loss per year, that's a measure of the energy that's lost per year, due to air infiltration, and also the dollars that are lost per year because you have to reheat the air that's lost due to air infiltration. Now, what is air infiltration? Air infiltration is when you have cracks in your houses. It's when you have holes in your houses that you haven't caulked. It's when you have any kind of windows or doors that aren't weather stripped properly. And air infiltration can account for 25% or even up to 50% of your total bill. On a typical household, if you add up all of the cracks and the holes in the house where the heated air is escaping, it can turn into a 3-foot by 3-foot hole. It's like leaving a door open all winter long. So it's really worthwhile to both use caulk guns and weather stripping, because those always pay for themselves in less than a year. And that's about 100% return on investment or more. So it makes sense to weather strip and caulk. You can even engage the children in this by putting saran wrap hanging from a pencil and letting them check where the drafts are in the house. If there's a draft, that means there's a leak. Secondly, it's worthwhile to know how much money you're wasting due to air infiltration. So if you look at the first equation on the air infiltration and conduction heat loss handout, you'll see it says 0.018 BTUs per degree day per square foot. Excuse me. It says I said that wrong. Scratch that. 0.018 BTUs per cubic foot of air degree Fahrenheit. Now, 0.018 is actually how many BTUs it takes to raise a cubic foot of air 1 degree Fahrenheit. So it's a measure of heat energy. Then you multiply by V, which stands for the volume of air in the house, which you can calculate just by taking the length of the house times the width of the house times the height of the house. That gives you feet times feet times feet, cubic feet, which is the volume of air in the house. Then you need to multiply by ACH. That stands for the air changes per hour. In a typical household, you will exchange all of your air with outdoor air once every hour. And then you have to pay for heating it all over again. The next figure in the equation is DD. That stands for degree days. Degree days is a measure of your climate, and typically it's based on a 10-year weather average. For instance, in Detroit, we have about 6,500 degree days. What that measures is how hard your furnace has to work to maintain comfortable temperatures in the home. It's typically based on a base of 65 degrees with the idea that people and appliances will add the extra few degrees up to 68 to 70 so people are warm. The last item is times 24. 24 just stands for hours per day. It's just to convert so that all of our units make sense. So if you multiply that out, 0.018 times whatever the volume is you get in the house, in the example it ends up being 16,000 cubic feet, times air changes per hour, in the example it's 1 air change per hour, times degree days, in the example it's 6,500 for Detroit, times 24, you will get the heat loss. You can see it right there. It's millions of BTUs per year. Now you take that answer in millions of BTUs per year, and now we want to convert it into dollars. How do we do that? Well, we have to take into account the cost of the fuel. In the example, it's just $5 per million BTUs, and actually, chances are it's much higher than that today, but we'll use that figure because it was given to us in the problem. So you take the BTU heat loss per year times $5 per million BTUs, which means $5 on the top of the fraction, million BTUs on the bottom of the fraction. Then you have to divide by the efficiency of the furnace, in this case 80%. And since 80% is a percentage, we first have to turn it into a number. Anytime you turn a percentage into a number, all you do is take the decimal point and move it 2 places to the left. So with 80%, it's 80 and then the decimal point. Move it 2 places to the left, and you get a number of 0.8. Take out that calculator, run the numbers, and you will see the dollars per year that it costs to heat that air due to the losses from air infiltration. Now the second equation that's on your handout has to do with heat loss due to conduction. Conduction is molecule-to-molecule heat transfer. And it has to do with heat loss out the walls and out the roof, not because of cracks, but because literally the warm air comes in contact with the drywall absorbs some of the heat and transfers it into the insulation, which then transfers it into whatever's on the outside of your house, brick or aluminum siding or wood, and then it gets lost to the outside. And this equation is similar but a bit different. The equation for conduction heat loss the equation for conduction heat loss is U times A times degree days times 24. Now you recognize the degree days times 24, right? That's similar. The U stands for the heat loss coefficient due to conduction, and the way we find that is by finding the R values of all of the materials in the wall. And an R value is a measure of resistance to heat flow. Like if you go to buy insulation, they will have a value for the R for that insulation. So you add up all the R values, and I give them to you in this example. And once they're all added together, 1 divided by the R is the U value. So in this case, I give you that the R value of this roof is an R of 30. That means the U value will be 1 divided by 30. A stands for the area of the roof. So that's easy. You just calculate the surface area of the ceiling. So it's just the length times the width of the ceiling. Now plug in those numbers. Take your calculator. 1 divided by 30 times the area in square feet times 6,500 times 24, and you can see there the heat loss due to conduction. The second equation for conduction heat loss is the same as what we saw up above with air infiltration. It's about converting BTU losses per year into dollar costs per year. So we take the BTU heat loss from conduction, multiply times 5, because that's what $5 is, it's 5.00, divided by 1 million, that's how many BTUs, and then we have to divide by the efficiency of the furnace again, 0.8. And there you go. Now you know how much it costs to heat the house due to the heat loss out that roof. So you have some examples that you can work on. Go ahead and try them. And if you have any questions, send me an email.